That may be one of the ways how we can take some advantage of lower power dissipation in electronic devices in a way. Now, if at the end of my talk you ask me, okay, what have I done with power dissipation? I have to say not that much, because so far we mostly worked on spin currents of this type, where the spins really move, they drift, diffuse in the material. We haven't used that much, at least in our work that I'm doing, spin currents that are based on spin dynamics, but we're just starting to make some good connections to that. So if you, at the end of the talk you ask me, so what have you done for power dissipation? So far not so much, but we'll see. Now, spintronics, a couple of years ago, like about 3 years ago, at the Intermag conference in Madrid, the organizers decided that spintronics as an idea is mature enough that it needs a roadmap, you know, like the semiconductor roadmap, let's say. And so they had a symposium on the roadmap for spintronics. And one of the suggestions that I liked very much was here, this one from Claude Chapert, who was at the University of Paris. Because also his roadmap was very simple, so it was very easy to explain what's going on. So essentially he said, if you look how spintronics as a field of research developed, it all started off as looking how charge transport is modified by the spin degree of freedom. And as time progressed, we were less and less interested in what the charge does and more interested in just the spin dynamics on its own. And so originally, it all got started by the discovery of giant magnetoresistance. And so what happens in giant magnetoresistance is you have several layers of magnetic materials separated by a non-magnetic material. And the resistance of this sandwich depends on whether the magnetization in adjacent magnetic layers are anti-parallel to each other or parallel to each other. And you change the orientation of the magnetization by applying an external magnetic field. And so the very first applications of spintronics ideas were based on these magnetoresistive effects, where you changed the magnetization with a magnetic field. For example, in a hard disk drive, this external field comes from the magnetic media. It's stray fields from the magnetic media that changes the resistance of your read head. And in the first magnetic random access memory device, you have a magnetic tunnel junction. And next